racing, or because they merge into each other. 1. Flying wing. The aircraft has no distinct fuselage or horizontal tail, although fins and pods, blisters, etc. may be present, such as on the B-2 stealth bomber. 2. Blended body or blended wing body. A smooth transition occurs between wing and fuselage, with no hard dividing line. Reduces wetted area and can also reduce interference between airflow over the wing root and any adjacent body, in both cases reducing drag. The Lockheed SR-71 spy plane exemplifies this approach. 3. Lifting body. The aircraft lacks identifiable wings but relies on the fuselage, usually at high speeds or high angles of attack, to provide aerodynamic lift as on the X-24. Flying wing. Blended body. Lifting body. Some designs may fall into multiple categories depending on interpretation. For example, many UAVs or drones can be seen either as a tailless blended wing body or as a flying wing with a deep center chord. Variable geometry, edit. A variable geometry aircraft is able to change its physical configuration during flight. Some types of variable geometry craft transition between fixed wing and rotary wing configurations. For more about these hybrids, see powered lift. Variable plan form, edit. 1. Variable sweep wing or swing wing. The left and right hand wings vary their sweep together, usually backwards. The first successful wing sweep in flight was carried out by the Bell X-5 in the early 1950s. In the Beech Starship, only the Canard 4 planes have variable sweep. 2. Oblique wing. A single full-span wing pivots about its midpoint, as used on the NASA AD-1, so that one side sweeps back and the other side sweeps forward. 3. Telescaping wing. The outer section of wing telescopes over or within the inner section of wing, varying span, aspect ratio and wing area, as used on the FS-29 TF glider. 4. Detachable wing. The WS-110 study proposed a long wing for subsonic takeoff and cruise, which then detached the outer panels to drop away, leaving a short span wing for supersonic flight. See also slip wing below. 5. Extending wing or expanding wing. Part of the wing retracts into the main aircraft structure to reduce drag and low altitude buffet for high-speed flight, and is extended only for takeoff, low-speed cruise and landing. The Gerin Varivol biplane, which flew in 1936, extended the leading and trailing edges to increase wing area. Variable sweep. Swing wing. Variable geometry. Oblique wing. Telescaping wing. Extending wing. 1. Folding wing. Part of the wing extends for takeoff and landing, and folds away for high-speed flight. The outer sections of the XB-70 Valkyrie wing folded down to enhance compression lift and directional stability during supersonic cruise. Many aircraft have wings that may be folded for storage on the ground or on board ship. These are not folding wings in the sense used here. Folding wing. Variable section, edit. 1. Variable incidence. The wing plane can tilt upwards or downwards relative to the fuselage. The wing on the Vought F-8 Crusader was rotated, lifting the leading edge on takeoff to improve performance. If powered prop rotors are fitted to the wing to allow vertical takeoff or STOFL performance, at extreme angles it merges into the converter plane class. 2. Variable camber. The leading and forward / or trailing edge sections of the whole wing pivot to increase the effective camber of the wing and sometimes also its area. This enhances maneuverability. An early example was flown on the Westland N.16 of 1917. 3. Variable thickness. The upper wing center section can be raised to increase wing thickness and camber for landing and takeoff, and reduced for high speed. Charles Rocheville and others flew some experimental aircraft. 4. Adaptive compliant wing. An adaptive compliant wing may be capable of varying span, sweep, chord length, dihedral, twist, camber, and thickness, as seen on NASA's Advanced Fighter Technology Integration, AFTI, Program F-111. Variable incidence. Wing. Variable camber. Aerofoil. Variable thickness. Aerofoil. Polymorphism, edit. A polymorphic wing is able to change the number of planes in flight. The Nikitin Shevchenko's folding fighter prototypes were able to morph between biplane and monoplane configurations after takeoff by folding the lower wing up into a cavity in the underside of the upper wing. The slip wing is a variation on the polymorphic idea, in which a low-wing monoplane is fitted with a second detachable slip wing above it to assist takeoff. The upper wing is then released and discarded once in the air. The idea was first flown on the experimental Hilson bimono. Polymorphic wing. Slip wing. Minor independent surfaces, edit. Aircraft may have additional minor aerodynamic surfaces. Some of these are treated as part of the overall wing configuration. 1 winglet, a small fin at the wingtip, usually turned upwards, reduces the size of vortices shed by the wingtip, and hence also tip drag. 2 strake, a small surface, typically longer than it is wide and mounted on the fuselage. Strakes may be located at various positions in order to improve aerodynamic behavior. Leading edge root extensions, LERGs, are also sometimes referred to as wing strakes. 3 chine, sharp-edged profile running along the fuselage. When used aerodynamically, it is extended outwards to form a lifting surface, typically blending into the main wing, as well as improving low speed, high angle of attack, handling, provides extra lift at high supersonic speeds for minimal increase in drag. Seen on the Lockheed SR-71 Blackbird. 4 moustache, small high aspect ratio canard surface having no movable control surface. Typically is retractable for high-speed flight. Deflects air downward onto the wing root, to delay the stall. Seen on the Dassault Milan. Additional minor features, edit. Additional minor features may be applied to an existing aerodynamic surface such as the main wing. High lift, edit. High lift devices maintain lift at low speeds and delay the stall to allow slower takeoff and landing speeds. 1 slat and slot. A leading edge slat is a small aerofoil extending in front of the main leading edge. The span-wise gap behind it forms a leading edge slot. Air flowing up through the slot is deflected backwards by the slat to flow over the wing, allowing the aircraft to fly at lower air speeds without flow separation or stalling. A slat may be fixed or retractable. 2 flap, a hinged aerodynamic surface, usually on the trailing edge, which is rotated downwards to generate extra lift and drag. Variations include plain, slotted, and split flaps. Some, such as Fowler flaps, also extend rearwards to increase wing area. The Kruger flap is a leading edge device. 3 cuff, an extension to the leading edge which modifies the aerofoil section, typically to improve low-speed characteristics. Span-wise flow control, edit. On a swept wing, air tends to flow sideways as well as backwards, and reducing this can improve the efficiency of the wing. 1 wing fence, a flat plate extending along the wing chord and for a short distance vertically. Used to control span-wise airflow over the wing. 2 dogtooth leading edge, creates a sharp discontinuity in the airflow over the wing, disrupting span-wise flow. 3 notched leading edge, acts like a dogtooth. Vortex creation, edit. Vortex devices maintain airflow at low speeds and delay the stall, by creating a vortex which re-energizes the boundary layer close to the wing. One vortex generator, small triangular protrusion on the upper leading wing surface, usually, several are spaced along the span of the wing. Vortex generators create additional drag at all speeds. 2 Vortilon, a flat plate attached to the underside of the wing near its outer leading edge, roughly parallel to normal airflow. At low speeds, tip effects cause a local span-wise flow which is deflected by the Vortilon to form a vortex passing up and over the wing. 3 Leading edge root extension, Lurks generates a strong vortex over the wing at high angles of attack. But unlike vortex generators, it can also increase lift at such high angles, while creating minimal drag in level flight. Drag reduction, edit. 1 Anti-shock body, a streamlined pod shape added to the leading or trailing edge of an aerodynamic surface, to delay the onset of shock stall and reduce transonic wave drag. Sometimes called a Kachelmann carrot. 2 fairings of various kinds, such as blisters, pylons and wingtip pods, containing equipment which cannot fit inside the wing, and whose only aerodynamic purpose is to reduce the drag created by the equipment. 3 Fillet, a type of fairing, a small curved infill at the junction of 2 surfaces, such as a wing and fuselage, blending them smoothly together to reduce drag. See also, edit. 1 Wing design features. 2 Aircraft design process. References, edit. Notes, edit. 1 Cap